Okay, so this is journal 64. We're going to start off with a bell work. And in this bell work, take a look here. It says on the first day you got 1 penny, the second day you got 2 pennies, and every day after you got double the amount of pennies. So how many pennies would you have after a week? And then how many pennies would you have after 30 days is what it's asking you. So first, I want us to notice that this here is a sequence, right? You get 1 penny on the first day, 2 pennies on the second day, and then every day after it doubles. So the doubling must be your pattern. So it's like I have 1 penny the first day, 2 penny for the second day, and if it doubles, that means if I have 2 on the second day and it doubles, that's like multiplying it by 2. I'll put a multiplication sign by 2. And so in this case, the next amount of pennies would be 4, and then 8, and 16. So I'm just multiplying by 2 every time. So this was my first day, second day, third day, fourth day, fifth day. If I want the first week, I need 7 days. So 6th day, 7th day. So I still need a few more. So 16 times 2 gives me 32. 2 times 32 gives me 64. So at the 7th day, or after a week, I get 64 pennies, or 64 cents, you can think of it. But that's not super impressive. So that's why I want us to also find what happens after 30 days, so about a month. How many, if this doubling keeps happening, how many pennies should we have in 30 days? So let's take a look here. Now, if I want to get to 30 days, I could just keep multiplying by 2 until I get to 30 days. But that's a lot of work, and I know you guys probably don't want to be sitting around and doing this tedious work, even though you can. So let's be smart about this. So take a look at these numbers here. So when you look at this number here, they're multiplying by 2 every time. So I know that if I were to create a formula, I need to be using 2 in some way. So because I notice it's multiplying by 2 every time, I can think about using exponents. And that's really the key to this. So 2 to the first power is 2. And if you think about this, 2 to the first power is 2. The second term here is 2. So now what I want to see if I can do is make the 2 my base and make the exponent here, the power here on the 2, the number of days that have passed. So let's try this. 2 to the second power gives me 4, right? And I have a 4 here. So this links up. 2 to the third power gives me 8. And so this is tied up with this. And so in other words, if I keep going down, this could be the possible pattern. I can write a formula, say a formula, that's 2 to the x, which represents days. But here's the thing. How can I make this work for getting 1? So what does 2's power need to be to get 1? Well, if you look at these numbers here, they're adding up by 1, right? This is 1, then 2, then 3, and the next will be 2 to the 4th power, 2 to the 5th power. So maybe this is 0, because you would go down 1 instead from 1. And so we would have 0. So what's 2 to the 0 power? Well, we learn anything to the 0 power is just 1. So this pattern actually works. In other words, this formula works. Here's the thing, though. Notice how the first term doesn't start at 1. It starts at 0. So if I were to use my formula here, I actually have to subtract by 1 for the days. In other words, instead of starting out 30 days, I would have to start out with 29 days. Okay, I would have to plug in 2 to the 29 to get how many pennies I would have in 30 days, because the number of the exponents doesn't start at 1 like the number of terms do. Okay, so let's figure this out. What's 2 to the 29th power? Because that will get us the total number of pennies in 30 days. So I got this really big number. I had to use my calculator here. So I got this many pennies. Now there are 100 pennies in a dollar. So if I were to convert this to dollar signs, I basically move the decimal place 2 times over. So that would give me 5, 3, 6, 8, 7, 0, 1, 9. Okay, let's take a look at this number here. It means that after 30 days, I got 5,368,709.12. That's a lot of money there. So after you double your amount of pennies, this is how much you would get on the 30th day. This doesn't even tell you how much total money you've accumulated after 30 days, but how much money you should be getting on the 30th day. So this is a lot. All right. So keep this in mind. This is going to actually help us with what we're going to be doing today. So you might have noticed that in this sequence, we are no longer adding or subtracting to find the next term. So arithmetic sequences was in the last journal, Journal 63, and we were talking about adding and subtracting in the sequence as a pattern. But this time around, we're going to be talking about multiplying and even dividing and how we deal with those types of sequences. Okay, so stay tuned for the next slide. So now we're going to be talking about something called the geometric sequence. So geometric sequence, unlike arithmetic sequence, we have this common ratio that we multiply by to get the next term. So in arithmetic sequence, to get the next term, you either add or subtract by a number that gets you to the next term. But in geometric sequence, there is this number or ratio that you multiply by to get to the next term. So to figure out if something is geometric, we have to make sure that that number, the pattern that the pattern in the sequence is multiplying by the same number every time, or is dividing by the same number every time. So let's take a look at this part A here. So part A here, if we look at the sequence, let's see if you can find the pattern here. So we go from a -3 to a 9 to a -27. So for me, I can see that this is multiplying by -3. So because it's consistently multiplying by -3, that means that this is a geometric sequence. So I'm going to say yes, it's a geometric sequence. And then once you figured out that it's geometric, you also have to state what we call the common ratio. So if you remember in arithmetic sequences, you have this common difference that you symbolize with D, which tells you the number that you add or subtract every time. In geometric sequences, you have this common ratio that you represent by R, which tells you what number you multiply by every time. So in this case, R is equal to -3, because that's the number we're multiplying every time. Okay, so next one here, let's see what we have. So part B, from -0.5 to 0, -0.5 to 0, and then from 0 to, I said that wrong. So from positive 0.5 to 0, then from 0 to -0.5, what is my pattern? So for me, I notice that this is subtracting by 0.5. So I'm minusing by 0.5 every time. Because this is subtracting, this is not geometric, right? What type of sequence would this be? Well, this is going to be an arithmetic sequence. So no, this is an arithmetic sequence because it is subtracting by 0.5 instead of multiplying. Excuse me. So watch out for what operations that they use. And last but not least, part C here. So let's take a look at this pattern here. I notice that this one is a fraction and then this one's a whole number. So what I'm going to do is make this 1 and put it over 1 to make it into a fraction so I can have a better look at what the pattern could be. So from 1 to 1 over 4, it looks like the denominator changed to a 4. And then from 1 over 4 to 1 over 16, well, it looks like the denominator got multiplied by 4 to get 16. So it looks like the denominator is being multiplied by 4 every time, but the numerator stays 1 every time. So because I noticed that the bottom is being multiplied by 4, I can say that this is being multiplied by 1/4. Because if you look at this here, if you multiply 1 by 1/4, you get 1/4. If you have 1/4 times 1/4, you get 1/16. You multiply straight across, and so that's our term right here. So because we're multiplying by 1/4 every time, this is going to be geometric, so yes, and r is going to be positive 1/4. I also like to mention that you could also think of this problem as dividing. So some people see this as 1 divided by 4 to get 1/4, and then they would take this again and divide it by 4 to get 1/16. But when you are talking about geometric, you have to represent it as the r as some number that you multiply by. And so that's why I wrote it as a fraction, 1/4. But this also implies as dividing by 4. Okay, so let's take a look at the next slide. Okay, so now let's talk about building a rule for a geometric sequence. So this formula here is going to help us do that. So if I want to find any term in a geometric sequence, I can figure out what that formula is and then figure out what term I want. So let's go over a few things, what these variables mean. So R, we just talked about, is what we call the common ratio. So it's the number that you multiply every time to get the next term. A1, that's just your first term. We've talked about this before. N is your term's position. So if you wanted the nth term, then if you wanted the 9th term, that means your n is 9. And A is just your nth term. So if you wanted the 9th term, this would be A9. A, and then this part would be a 9. So now that we know what each one means, let's use the formula, let's use a sequence. Given a sequence, we're going to create a formula or a rule. So we're going to write a rule for the given sequence. Now, this sequence here, let's take a look and see if we can find the pattern. 5 to 25 to 125. What's the pattern? Well, for me, I can see that this looks like it's multiplying by 5. Right? So from 5 to 25, you had to multiply by 5. From 25 to 125, you had to multiply by 5. So that tells me that my common ratio needs to be 5. My A1 here, my first term in the sequence, is 5, as you can tell from here. So I'm going to grab that 5 and write it for my first sequence. And I think that's all I need. When you're trying to build a sequence, you need to have the first term and the common ratio to build a rule. So 2 ingredients. So that means my AN is equal to A1, which is my first term. So I'm just plugging these numbers into the formula now. So I'm plugging 5 into A1. My R here is 5 as well. And this is raised to the n minus 1. I always put the R in parentheses because I'm raising it to a power. So just keep that in mind. So when I look at this here, there's nothing for me to simplify inside the parentheses. Neither there is outside. So I'm going to keep my answer like this. So that is my answer. With this next problem here, we're going to do the same thing. We need to find a first term and the common ratio. So looking at the sequence here, it looks like our first term is 2. So I'm going to grab that 2. And the patterns on my common ratio. So 2 to get to 10, I need to multiply by 5. 10 to 50, I also need to multiply by 5. So it looks like the common ratio is positive 5 because I'm multiplying by 5 every time. From here, I'm going to build a formula. So I got to plug these values in for my formula. So this one goes into A1, this one goes into R. So this is an equals my first term, which is 2. R is 5. And this is going to be n minus 1. And again, I can't simplify this any further because there's nothing inside for the parentheses to simplify or combine with, and the 2 is outside. Make sure you don't try to distribute the number outside into the parentheses. The reason why you can't do that is because this has an exponent, okay? So don't try to multiply that number on the outside with the number on the inside. So I'm just going to keep my answer like this. So that means that if now I have like a formula here, if I wanted to find the 25th term, all I have to do is plug in 25 for n and solve that out. So let's take a look at C next. So for part C, notice that it doesn't give you A1 this time. Instead, it gives you A3. But it does give you the common ratio, which is nice. So even though I have A3, I still need to get A1, the first term, because I need the first term and the common ratio to build a formula or to write a rule. So how do I go about finding my first term? So that's the question. Like, how do I find my first term? Well, I can do this by taking in what I know. So, or plugging in what I know. So I know that A3 is 16, so I know I can use A3 for my advantage. So A3 is going to be the nth term. Oh, my bad. The nth term. So A1, I don't know what that is, so I'm going to keep that a mystery. Or keep that as a variable. R, I do know. R is 4. N, if I choose A3 to be my nth term, that means n is equal to 3. So we have 3 minus 1. Okay, so take a look here. This A3, you actually know what the value is. It's 16. So I'm going to replace this A3 with 16. So now notice I just have A1 left over as my unknown variable. I'm going to clean this part up a bit. So I'm going to drop down the 4. 3 minus 1 gives me 2. If I work this out, 16's on this side. A1, I'm going to drop that down. 4 squared is 16. So I'm multiplying this A1 by 16. If I want to get rid of the 16, I have to divide by 16 on both sides. That cancels. So A1 is equal to 16 divided by 16 is 1. Okay, so now I have A1, but I'm not to my rule yet. So remember, if I have A1 and my common ratio, then I could just plug it into the formula. So the last part's pretty easy here. If I plug this into my formula, I have AN equals A1, which is 1. My ratio is 4, and then n minus 1. And so here's my rule. But what I also notice is that there's a 1 in front of this parentheses. And so if I'm going to be multiplying something by 1, it's going to end up being itself. So in this case, I can really write this as AN equals 4 to the n minus 1, just to be less redundant. But I would have taken your answer if you left it like this too. So here is our answer for part C. Okay, so we're going to do a few more example problems using that formula that you just saw a moment ago. So that formula there in the last slide was that's a highlighter. AN, so this one's for geometric series. So A1 times R to the n minus 1 power is for geometric sequence rule. Okay, so from here, let's take a look at what the problem wants. So this problem wants AN, the nth term basically. So looking at the sequence here, we have a sequence. We want to find the 9th term. So A to A9. How do we go about doing that? So if I want to find the 9th term, I could possibly use this formula. However, I'm only given a sequence. So if I want to use this formula here, I have to build the formula.
So to build the formula, I need what A1 is. So A1 is the first term, which is 5. And then I need the common ratio, so the pattern. So it looks like you're going from 5 to 15 to 45. So it looks like I'm multiplying by 3, because 5 times 3 is 15. 15 times 3 is 45. So my common ratio is 3. So based off of this, that means my rule is going to be 5 times 3 to the n minus 1. And so from here, if I want to know what the ninth term is, all I got to do is plug in 9 for the n into my equation. So that means I have a 9 minus 5, sorry, not minus, equals 5, 3 to the 9 minus 1. So if I work it out, I have 5, 3 to the 8th power if I subtract the exponents. And so now I'm left with, okay, well, 3 to the 8th power. I'm going to have to use my calculator for that. So 3 to the 8th power gives me 6,561. If I multiply that by 5, I get 32,805 as my my ninth, which makes sense because this number is huge, but you have to think about it. You're going to be multiplying by 3 every time for the previous number. So in this case, as you're multiplying by 3, the number gets bigger and bigger. So by the time you get to the ninth term, it should be a pretty big number. So this is the ninth term. So box that in. Let's try that again with this one here. Notice that this one, I don't give you the sequence. I actually give you what A1 is. I give you the common ratio, and I give you n. So if I ever give you n, that is implying that you're going to be finding the nth term for that n value. So in this case, I need to find the 6th term. So A6 is what I'm looking for. To do that, again, we need to create a formula here. So this time we don't have a sequence. We have actually already A1 and the R. So AN is going to be 729. R is negative 1 over 3, n minus 1. And so from here, if I want to find A6, then all I have to do is plug in 6 into this equation. So from here, I will probably need the calculator to help me out with the computation here because of the powers. So I have 729. I'm just going to subtract that exponent there. So I have 6 minus 1, which is 5. And then from here, I need to figure out what 1 over 3, negative 1 over 3 to the 5th power is. So I'm going to grab a handy calculator here. And I'm going to do this in the graphing calculator. If I raise it to the 5th power, I get 729 times negative 1 over 243. So when you take this guy here and you raise it to the 5th power, you get this amount. And then if I multiply this fraction by 729, I get negative 3 here. So A6 is negative 3. Or the 6th term here is negative 3. All right, so this should help you out with page 3 of that packet. So now I would try out some problems on page 3 of packet 14.